Okay, here we are at factoring review 2. I hope your e-cart went well, and I'm excited to look for all your scores. So remember the number puzzles that you did for homework last class. Your number on the left is going to be your sum, and your number on the right is going to be the product. Keep in mind, if you have a negative value, this actually, even though it is the sum, we know it's the difference because my signs don't match. So watch your signs carefully as you fill in here. All right, moving down, we're going to jump in and start talking about what factoring is. And we're going to start with looking at the opposite of factoring, which is multiplying. When you multiply binomials, we're actually using the distributive property to multiply each value by the others. Lots of times math people call this FOIL. It's a nickname that we use for our first term, our inner term, our outer term, and our last terms. So for example here, the product of my first terms is x squared. The product of my outside terms is going to be negative 5x. I should have reversed these, first outer, inner, last. My outside product is x times negative 5. My inside product is 2 times x. And my last product is going to be 2 times negative 5, which is going to be 10. So what ends up happening a lot of times is your outer and inner terms can be added together, and then we can combine like terms and call that their sum. So go ahead and multiply these and see if you remember how to use the distributive property to multiply. Come back and check your answers. All right, after you've done your work, you can check it with mine. I went ahead and showed you each of the individual factors, my first terms, my outside terms, my inside terms, my last terms, and then you recognize that frequently, not always, but frequently, these two middle terms can be combined. Notice if I have a coefficient here on this x, he's a part of that 2. So when I have my 2x times 6, that's my 12x. So when I combine these like terms, I get 17x's. This one's kind of fun because I get this 0 pair because my positive 7x and my negative 7x are a 0 pair and cancel out. This is a special pattern we're going to call the difference of two perfect squares. And that is the result of a sum and a difference as the factors. Here I have a perfect square, x plus 8 times x plus 8. Notice I end up with identical middle terms, which ends up giving me a double as my middle term. When I multiply these together, I have to be careful of my signs. I have a negative 9x, a positive 2x, and thus they combine together to have a difference of negative 7x's. Now this is a most missed conversation here. Frequently, kids go ahead and just call this x squared plus 49, but notice these middle terms represent that negative 14x's. Our hint for you is if you're one of these people who is tricked by this, take the time to write out x minus 7 squared as x minus 7 times x minus 7. All right, so flip over to the second page, and we're going to talk about what it means to factor. So a factor is a value that can be multiplied, but when we think about the term factor as a verb, that means breaking down a value into those values that are multiplied to get it. In mathematics, we need to be able to factor so we can simplify expressions, cross out common factors, and that includes a lot of division. We can also solve equations beyond having x to the first power. And those quadratics that you solved at the end of algebra, that you'll start algebra 2 with, need to have factoring as your first step. We're going to think of factoring as unpacking a suitcase, where you're taking out all of the different factors. The easiest place to start is where we talk about our greatest common factor, and we abbreviate that as the GCF. You're looking for the biggest value that can come out of expressions. Our biggest things that we look for is whether or not you can take out a negative value out of everything, whether there's a common coefficient value or a common variable. So when you're finding the GCF, you're going to break down our values into all of the different factors. I can break 9x down into 3 and 3, and then that x is a value 2. 45 we can break down into 9 and 5, and then of course 9 breaks down into 3 and 3. When we're looking for the greatest common factor, we're going to look for the greatest value that can come out of both. So in here, our 3's are what are common. So the greatest common factor out of these values would be 9, because I can evenly divide a 9 out of both things. For these values, I have a 5 and 4 y's. In 10, I have a 5 and a 2 and 2 x's. And I have 2 y's here. So when I look at what the greatest value that can come out of everything, both of these values can be divided by a 5. And both of these values can be divided evenly by 2 y's. So that is going to be my greatest common factor. If I have a negative that can come out, that's going to make more sense when we get down and talking about these equations. So when we talk about what can come out of here, a 15, 6 x's and 3 y's. I have a 45, 1 x and 3 y's. So my greatest factor that can come out is 15 comes out of both. Only 1 x can come out of both, but all 3 y's can come evenly out of both. So when we're talking about what is the greatest common factor, we're looking for the biggest value that can be divided out of both. When we have a polynomial expression, which is what you're looking at here, you want to try to find the greatest factor first that can come out. And when we factor it out, we're going to pull it out and undistribute. So with our distributive property, we take that coefficient and we share it out to every single term. In this case, we're going to divide out every single term, leaving us with a polynomial. A good test for you to do is see if you can put it back in, put this factor back in, and get the same value. Whatever you can take out, you need to be able to put back in. So if I look at this term here, this is where I'm going to look at including that negative value that can come out. If I take a negative and a 3 and an x out of each term, what am I left with? A positive x squared here and negative 2x here. And this is so important. When you divide something by itself, you're left with 1. This 1 is a most missed part of this conversation. Think about taking this 3x and this negative 3x and putting it back in. Negative 3x times x squared is negative 3x cubed. Negative 3x times negative 2x is positive 6x squared. And negative 3x times 1 is negative 3x. So you want to make sure that when you take that factor out, it can come back in. Go ahead and pause the video and try to find the greatest common factors for these polynomials. All right, so let's see how you did. This negative 9 y squared comes out, and notice my a and my b and my c are left behind. They are not common factors. My 3x comes out, leaving me with x squared, 2x, and negative 5 in number 4. Number 5, I'm going to take a negative 2 and an x out, leaving me with positive 2 times x plus 3. And check out this one. 8 is made up of 2's and 4's. 6 is 2's and 3's. 9 is just all 3's. So there's no common factor between them. This is all x's, this is all y's, and this is all z's. So I have no common factors in that polynomial. All right, so when we talked about your number puzzle, that is a way for you to think about finding two numbers with a sum and a product, and that's what you did in the last factoring worksheet and on the front. And what we want you to do is see if you can figure out those two values that make that true. If you look at what we have here, each of these polynomials is a product of what we had on the front worksheet. See how I ended up with a quadratic, that's that 2, trinomial. This is the product of these two things multiplied together. So where we're multiplying here, now we're going to do the opposite by factoring. So when we're looking at factoring, we're talking about breaking this down into the two numbers that were multiplied to get it. And here's where our number puzzle comes into play. If I have a sum of negative 5 and a product of 6, can you think of the two numbers that fill in that number puzzle? Those two numbers will complete your algebraic expressions that are your factors. This x splits into x times x because x times x is x squared. If I think about two numbers that multiply together to give me a positive number and a negative sum, both of those numbers are going to be negative. If I think about 6, I can do a factor table of 1 and 6, 2 and 3, and here's my wraparound. So 2 and 3 have a sum of 5. If they were both negative, then I could say x minus 2 and x minus 3. If I test it with FOIL, my first terms, x times x is x squared, my outside terms, negative 3x, my inside terms, negative 2x, and my last terms, positive 6, that first, outer, inner, last gives me a polynomial product of this. Here are my two factors. Let's try another one. Here's my number puzzle. Now notice I have a negative here. Let's go ahead and factor that out so we're only dealing with positive leading values. My goal is to break this down into the two factors that multiply to give me this product. I'm looking for the two factors. I want two factors that have a sum of negative 9 and a product of positive 20. So we'll go ahead and we'll break down 20, 1 and 20, 2 and 10. 3 does not go in evenly, but 4 does, and there's my wraparound, because my next is 5 times 4, 10 times 2, 20 times 1. Notice 5 and 4 have a sum of 9 if they were both negative. A positive product and a negative sum means that both of these values have to be negative. My x squared splits into x times x. My 20 is the product of 4 and 5, and my negative 9 is the sum of negative 4 and negative 5. Let's check it. X times x, x squared. Negative 4x plus negative 5x, negative 9x. Negative 4 times negative 5, is going to be positive 20. Our first terms, our outside terms, our inside terms, and our last terms. Don't forget about this negative. This negative is going to be a factor that everything has to be multiplied by. Why don't you have a go at 3, 4, 5, and 6 and see how you do. Okay, let's see how you did. When we look at these problems, we want to make sure that first of all, we remember how important our GCF is. Taking out that greatest common factor here and here and here made our polynomial that we were left with a lot easier to work with. Be very careful of this one where you take out the negative, because that makes each of these signs then positive. And you want to make sure that when you're looking at your number puzzle and your factor trees, that you're looking at and paying attention to how your signs work out. So here I needed a positive 5 as a middle term. That's a positive 10 and a negative 5 that gives me that difference of positive 5. Notice here my sum is negative, but my product is positive. That means that these two values have matching signs. A negative times a negative is a positive, and negative times negative plus a negative is a negative. When we look here, we were worried about these negative signs until we realized, oh wait, I can factor them out. All right, so when we consider whether or not we can get some help from our calculator, absolutely. Because if you look at a number like 96, we can't always know how that can break down. That's outside of my friendly numbers, and so that might be a little bit more difficult. So here's a calculator trick for you to try. If you go to the function screen of your calculator, and that's this y is equal to button right there, you can type in an equation where you ask for all the factors of that number. So whatever number you're looking for goes here, and you're asking for it divided by, and this x represents all the different values of x that's possible. So now if you want to go to your table of values, that's a second function, and what you're looking at is all of the values that can be divided. So those factor tables that we were making on the front side of this, that's actually what you're looking at here. 96 is 1 and 96, 2 and 48, 3 and 32, 4 and 24. We're not going to worry about 5 because that doesn't go in evenly. 6 and 16. 7's not evenly divisible. 8 is. 9 is not. 10 is not. 11 is not. And 12 is, but there's our wraparound. So we don't have to worry about 12 and 8 because with the commutative property, we already have that value represented. So when it comes time for looking at your factors, if you're looking for two numbers that have a product of 96 and a sum of 28, this looking at this input and output on our table can certainly help you. So when I'm looking here at my factor, if I want to break this down, I can draw my two binomial expressions. I split my x's, and I know here that if I'm looking for a sum of 28, there it is. So I know that x plus 4 and x plus 24, if I multiply these two together, first, outer, inner, last, this is my product. Here is my product, and here are my factors. All right, so you've got a bunch to try. We gave you a number of them. Look for greatest common factors that can come out. I know that a 3 and an x can come out of this one before I factor, and I know a 5 can come out of this one before I factor. Take a negative out of this one before you factor. Keep in mind it doesn't always have to be x's. So when you draw your two binomial expressions, this first value that's going to be in here is going to be the square root of this first term. Our p's split to here and here. You're going to need to consider taking out a negative, a 2, and an a out of this one. These two are pretty straightforward, as is this one. If you flip over to the back, you have lots of opportunities to find some greatest common factors and some factors for each of these. Now I'm looking at this one right here, and this one's kind of suspicious. Here's why. When I look at 9, 1 and 9 and 3 and 3 are my only factors of 9. If I'm trying to get a product of -9 and a sum of -2, I'm curious about this one. Do you know what we call something that cannot be factored? Because it's possible that some of these don't work out. So if you are unable to work it out and factor it, we call it prime. Something else to think about, don't forget your GCF. Maybe that'll be important for this one. All right, good luck with this, and we'll check back in and talk about these when I see you next.